Hello and welcome to today's video. In today's video, we are going to look at chemical kinetics, and we are going to start by looking at the rate law. So what is the rate law? So a rate law is just an expression. It's an expression that shows the relationship between the concentration of the reactants and the rate, or it's the relationship between the rate and the concentration of the reactants. It's given by an expression rate, provided that this is the reaction. So it's given by K-A-N, where we know that N represents the order of reaction. Now, without wasting much of your time, I want us to look at the types of rate law. So under rate law, we have two types. The first type is known as the differential rate law, which is commonly known as the rate law. Then the other one is known as the integrated rate law. Now, what is the difference? So the only difference is that this focuses on the relationship between the concentration of reactants and rate. So to use this, our focus area is to see the relationship between how the concentration is changing with the rate. So here it's about the rate and the concentration. Then for integrated rate law, here the relationship focuses on the concentration of reactants and time. So this is the function, the concentration. As the concentration is changing, how is the time also changing? So it's the concentration as a function of time. Now, how do we derive these integrated rate laws? So we'll start with what we call the zero order. So when they say zero order, your N is equal to 0. Now, we know that rate is expressed as negative change of the concentration divided by the change in time. Then rate law is given by K, then the concentration of A with the order of reaction. So when we put these two together, we have an expression like this is equal to K, A, then N. So when we say zero order, our N is equal to 0. So by substituting 0 in this formula, so we have this then change time k a 0. Then we know that anything raised to the power 0 is 1. Therefore, this means now changing these to differential, this can be written as negative d function of a dt is equal to k. Then leaving the a as the subject and taking the negative to the other side, so it becomes the a negative k then dt. Then if we do the integral of this, I hope we know the basics of integral. So if we have dx, it means that we have x to the power 0. So when we do the integral of this, it means that it's x, the rule is n plus 1, then n plus 1. So when we do the integral of this, that is from the initial of this to the final of that, then from 0 to t, this gives us a minus initial, then negative k. This is going to be t minus 0, which is just t. Now writing this expression as y mx plus c, it is written as a, then we take this to the other side, so it becomes negative kt plus this. So that is the equation for a 0 order. Now from here we can also determine what we call the half-life. So to determine the half-life of this, I want us to be looking at the equation. So So when n is equal to 1, it means that the change in the concentration of A so anything raised to the power 1 is raised to the power This is the equation for the second order, for the first order. Now, to find the half-life, so remember at half-life, we know that this will decompose to that. So looking at the equation, which is the ln A is equal to negative KT ln naught. Okay, so substituting this equation to rewrite this equation, when we take it back to here, what that simply means is ln of A divided by ln of A naught is equal to negative KT. We can also write it like this. So substituting using the half-life, this becomes ln, so half of this, then that is negative KT half-life. So when we do the math here, we find that we have the ln of 2, the negative KT half. So when we punch on the calculator, this gives us a negative 0.693 negative KT half-life. So it's negative K, negative K. Therefore, the half-life is given by 0.693 divided by K. So that is how we determine the half-life. Then the last one is the second order. So the second order, here we're saying n is equal to 2. So the change in the concentration of A divided by the change in time is given by K, A, then N. So in this case, it's the change in this divided by this gives us the K, then A, 2. So when we do the dA dt, I take the negative to the other side, so negative K, then A2. So divide A2 throughout, so A2, so that and that will go, then cross multiply, so this becomes 1 over this, then dA negative K dt. So according to integration, when we have an expression like this, we prefer to write it as x negative 2. Then we use the x plus 1, then n plus 1 expression. So when we do, before we integrate, this is the same as a negative 2, then dA, then negative k dt. So when we do the integral of this with the limits initial to final, the limits 0 to t. So what this happens is when we integrate this, it becomes x negative 2 plus 1, then negative 2 plus 1, which when you do your math, this becomes negative 1, then this becomes negative 1. So this means negative 1x. So this is what is happening. So here it becomes negative 1 over this, then minus again negative 1 initial, then negative kt. So to continue, this becomes negative final, then this gives us plus initial, then negative kt. So again, rewriting this as 1 mx plus c, making this a positive, it means you multiply throughout by a negative, so it becomes 1, then this becomes minus this, then this becomes positive kt. So to rewrite it becomes this kt, then goes the other side, is plus 1. So this is the second order expression for the integrated rate law. Now to find the half-life, so how do we find the half-life? So half-life, we know that this is half of the time taken for the original, half of the original to decompose. So we're going to substitute this into that. So this basically means when we go back to the equation we take this to the other side, it's minus this, then is equal to kt. So at half-life we are changing this to 1 over this naught by 2 minus 1 over this, then kt half. So what this simply means is 2 naught minus naught. which is k, then t half. When you do the math here, it's as same as remaining with this, then k, t, then half. So to find the half is we just multiply throughout by this, so that this and this will go. Therefore, the half-life be given by 1 over initial then k. So that is how we derive the integrated rate laws, and these are very important to answer questions in exams. Thank you, and see you in the next video.